So hello everybody. We'll go ahead and get started. We had a little hiccup there with my camera, but this is another version or session of our database and memory office hours. I'm privileged today to have Allison Holloway as a guest. She's one of our development managers in database and memory, and currently specializing in some of the pushdown that goes on within database and memory. So I thought it'd be fun to have her as a guest, and for any questions that you guys have that I can't answer, or some insight perhaps that she can provide to go along with some of the demos I'm going to show about how basically I have a couple slides, we'll talk about it, but the ability to do more work during the scan of the data than having to wait for rows to be returned. So that's part of what gives database and memory a great speed up. I have our main page here. Maria's not with us today. Again, Allison's here. But I did want to point out that we do have down below on that page, our main landing page, not only all of our other office hours sessions we've done, so they're recorded if you want to go look at those. And then in addition to that, we have our resources. So if you want to go look at our blog, I always talk about our resources page, which I'll show it to you, but you can click on there. We have our other white papers and information, other videos, and of course the documentation, and then our in-memory advisor. So if you want to try to see, do you have analytic workload that might take advantage of database and memory, you can run the in-memory advisor against even without database and memory enabled, or even not a 12C database. So it goes all the way back to 11.203. And we talked about that, and there's actually some AskTOM sessions. You can see back in February, we did a whole session on that. So if you want to check that out and then try it on your own to see if database and memory might help, given that one of the other things we've talked about recently is the base level feature. So you can even try database and memory on 19.8 or higher. Currently, I guess that's 19.8 or 19.9, but soon we have the 20C pre-release, and then the next version of Oracle will continue. They allow you to, to use database and memory with up to 16 gigabytes of column store. So you can even try it out without having to license database and memory first. So if that's of interest, you can check that video out as well. I think we actually did two of those. We did one on the base level and then one with the ability to do that. We backported it to 19C. So other than that, I think the only other housework to talk about is all of you, the attendees will be muted, but you can certainly ask questions in the Q&A panel. We'll try to get to answering all of those questions, and they don't have to be just about what we're talking about today. It can be any question related to database and memory is fine. But we're kind of like to have a certain topic, and so we're going to do that with pushdowns. So let me get rid of that page for now. And I have just a few slides to kind of introduce what we're talking about, and then we're going to jump into some examples. So I'm going to kind of be looking away. I apologize for the camera thing, but anyways. So again, Allison is part of the database and memory staff. My name is Andy Rivenes. I'm a product manager for database and memory. And so with that, we'll go ahead and get started. Safe harbor. I don't know how much futures we'll talk about, but it's possible since we do have some new releases in the works getting ready to come out. But let's talk about pushdowns. So we've got actually several blogs that we've done in the past about pushdowns and this topic. So if you're interested, you can go back and look at those. And I've created some demos kind of around these topics that we've talked about in the past, but I thought it would be fun to talk again about it and maybe go into a little more detail. So we have the first blog was making queries fast. Maria did a part 2 to that, and then we talked about single table group by, and we'll kind of show you all of that as well. And so database and memory actually does other pushdowns as well. Kind of the goal, I like to tell people, kind of the goal is to do as much work for the SQL query execution as possible during the scan of the data. So even hash joins can be turned into scan and filter operations. We've done some sessions on how hash joins work, in-memory aggregation. But I thought it'd be fun to step back and kind of look at how just the basic pushdowns actually work. So with that, we'll continue on to scan for questions. If you guys have questions, let us know. And again, that goal is simply to do as much work as possible during the scan of the data. And some mechanics here, execution plans. So some of the pushdowns, and I'll show you some execution plans, actually will show you if, for instance, filter predicates were pushed into the scan, if the optimizer decided that those would make sense to push into the scan of the query. You can use both DBMS XPlan, which is what I'll show you today, or SQL Monitor Active Reports, or DBMS SQL Monitor. You can use the text version as well. That does sometimes require the monitor hint if your query is too fast. So sometimes I'll tell folks that, well, I really need to see a SQL Monitor Active Report to see where time was spent. But if your query is very fast, doesn't do very much I/O or CPU, or is serial and not parallel, sometimes you have to put a monitor hint in. So I just kind of put a hint for that. Session level statistics is another area where we're able to show you what work has actually been done. A lot of times folks want to know how much benefit did they get from database and memory. And then I will typically recommend in our the quick start guide and in our implementation guide is if you want to, especially if you're evaluating whether database and memory can help you or not only is obviously the elapsed time or response time valid, but and that's kind of what we're looking for as our main criteria. But what happened? How did database and memory speed that information up? And so we have some blog posts about statistics. So statistics in general, and then execution plans can help you determine did database and memory get used, and what parts of it helped speed up that query execution. And so that's kind of what this is about. So then I have some examples. I'm going to just I have 3 examples we're going to talk about. I'm going to talk just briefly here about them to give you some background, and then we'll go to the demos, and because that's actually more fun to do, to run the actual queries and see what happens in the real database. But predicate pushdown. So where clause filter predicates can be typically pushed down into the scan. In this case, it's just a query of the line order table. We're just counting how many column values or quote rows, but really column values are going to get returned based on the discount, quantity, and order date. And so rather than in the row store where we actually have to return the rows from the line order table and throw away rows that didn't meet these filter criteria, we can actually do this during the scan. And this is what gives us one of the things that gives us extremely gives us faster performance. And so we can see that both in the execution plan and then in the session statistics. Not only that, function-based aggregation can also benefit from pushdowns. Actually, I have count there, but that's probably not right, Allison. Do counts don't actually get, well, I guess we do it at the IMCU level, the result coming back, right?
Yeah, I mean, so all of these aggregations are, I guess you can call them partial. So you can do them on the IMCU, and then we return them, and then the upper layer aggregation row source then aggregates our aggregations.
So we'll talk a little bit about how that works, because we can see that in the projected rows projected coming back to see that. So we'll look at that in the statistics. And then I was just thinking that because in my example I had a count, and then single table group by. So not only can we for multi-table group bys or in-memory aggregation where you might see a vector group by, single table group bys will also take advantage of pushdown technology. I think that was 12.2 where we actually enabled that and made that useful for pushdowns. And we'll talk a little bit about that as well. And feel free to jump in and add any information that you want, Allison, no problem there. And so with that, I think, so those are going to be our 3 examples. So then what I have is on my VirtualBox, so I didn't want to have to depend on going remote for a different system. I have a 19.8 database running. I've got our SSB schema populated, so it's fully populated, and those bytes not populated is 0. It's a single instance database. We won't use parallel query in this case because it'll just be simpler to run these as serial queries. And so that's kind of the makeup of what we've got. And we're really, in this case, really only interested in the line order table. And so with that, I have several demo scripts, so you wouldn't have to watch me type, which is sometimes painful. And so for the first query, I decided, whoops, I'll fix that in a second. So for the first query, what I have is, we're going to look at the filter predicate case first, because it will show up in the execution plan, and then we'll look at the aggregations. So it's basically that same query, just doing a count, and we have some filter predicates added to the query. And if, let's see, I had trouble with this, and I wasn't sure why it wasn't accepting my page. No, still not. All right, well, we will fix that. For some reason, I needed to do column format ahead of time. We're separate, so let's see. See if this looks a little prettier. Yes, and I don't know why my column isn't being taken. So same query, and we see from the session level statistics that we have 111 IMCUs is populated part of the line order table. And then what I usually like to call out in I have a blog post that was in the presentation, which will be available, rows projected. So notice that we get basically the results of the scan of each of those IMCUs back. Again, that matches 111. And although there were almost 60 million rows scanned, so we did work in each of the IMCUs as we scanned the line order table. And then if we look, we can see that we had some other statistics that talk about P code. I don't know if, Allison, you want to briefly talk about P code? You don't have to get into any technical details per se, but what we're doing under the covers, since we exposed the statistic.
Okay, so P code is our representation of how we do like the where clause, and then also including the aggregates. And Shashank was the one who named it. I think Shashank has done some AskTOMs with you. Yeah. So I guess we have a few different stats. So there's aggregation push down, which says that, we had an aggregate, so min max count, something like that, we could push down. The P code pred eval is how many predicates were evaluated. So I think there were 111 CUs. So it looks like there were kind of 5.
And there were 3 predicates, right?
Yeah, so I don't know where the 5, but why,
so
why
it said 333. Oh, these here, yeah, I'm not sure why that goes, but I think this makes sense, doesn't it?
Yes, yeah, so the predicates applied and the predicates received makes sense. So I don't know if there's some stats from a previous run or something.
No, I just connect. Well, actually, it could be from the. Good point. Let's try that.
Oh wait, is there also is there a count star on this one?
Yeah, it's a count star, so it may be from that. But let's try. Oops, I'm gonna just go back and cut and paste one more time. Although I did a connect. I had a connect on there.
Okay. So then, I'm sorry. The predicates applied might also be including something from the aggregate.
Yeah, that one. But the bottom line is we see that we applied our predicates. We basically looked at all 111 of the IMCUs. There's a total of that many rows scanned, but obviously we're only bringing back. I think the way the mechanics work is we're only really bringing back the counts, 111 counts, one for each IMCU, and then the upper layer aggregates that 111 into a total count, which is much faster than having to do each individual row.
Yeah, and if you notice, there's this IM scan rows P code aggregated, and so that should be the number of rows that passed the filter.
Where I am
So
rows.
like right after IM
right
scan rows, there's IM scan rows P code aggregated. So
and then so of the 60 million, that number is how many that actually met the filter predicate criteria?
Yes, I believe so.
And then actually, well, we could actually go look and see that that number matches here, which we'll see in another example as well. So there you go. So again, one of the big benefits of database and memory is the ability to do this work during the scan. And so we can even walk through that within session statistics, which is typically the simplest way to get that information if you know what you're looking for. And I do have, I put in here for folks that are going, oh my gosh, how am I going to figure that out? I do have a link here. So we did do a description of some of these statistics because some of them aren't in the SQL reference, the reference manual, database reference manual, where we describe all the statistics. So the popular ones, we actually went into the blog post and described what they're doing. So that can help you if you want to go back to see, well, what do some of these statistics mean? Not all of these will be described, but certainly, for instance, this guy, or I'm sorry, and project rows projected, and IM scan rows projected. Some of those statistics are described there, so it's a little easier to kind of figure out what some of these statistics mean. But the reason I did this one first, although I probably could have done the execution plan first rather than the statistics, demo 1B.
Yeah. And I'll add two things. So one, I'll definitely put in another plug for the blog. I know that a developer who has worked on the in-memory project since the very, very beginning. Sometimes it's the easiest way to find some information, even for me, like in an area that I haven't worked in, and it's well done. And it's like, okay, oh yeah, that's what I wanted.
Even our developers use the blog. That's cool.
Yeah. A plug for that. And then also, so if you're looking at doing the stats, then it's easiest when you're doing it with a serial plan, and especially without, and I don't know if you've ever done a session on this, the IMDS.
This environment doesn't, but like the one I sent you, it's a bigger machine. It'll show up in there as well.
Yeah. And so if either of those, so if either PQ or IMDS are on, then it's a little bit harder to do this one-to-one correspondence with the stats. So you have to know a little bit more about what's going on. And so it's not always going to be one-to-one. Right. But for the serial without IMDS, you should be able to see it.
And for those that might not be, so PQ being parallel query, serial queries are usually easier to use to do troubleshooting, if you will, or kind of experimentation. Parallel query, though, will get aggregated with SQL Monitor active reports, so that helps. But and then IMDS is in-memory dynamic scans. We've talked about those, but that's our way of works with parallel query or without, and it's our ability to internally parallelize the scan of each IMCU, so in-memory dynamic scans. So that's what Allison's referring to. And so I ran the same query, but this time I'm going to show you an execution plan. And I've talked about this in the past, but it's the same query. We see table access in-memory full, and we see our the costs. But in the predicate information, now you see the optimizer telling you that it's going to push these filter predicates. Notice, normally if database in memory wasn't enabled, these two lines here wouldn't be there. The filter lines would be there, but the in-memory lines wouldn't be there. So for filter predicates, the optimizer will tell you that, or at least it's going to attempt to push those filter predicates into the scan. So you're going to get benefit not only from being able to do an in-memory scan, but also being able to do additional work during that scan to speed it up even further. And so that's kind of a nice visual or a way to kind of verify what's going on. Unfortunately, that doesn't happen with the function-based aggregations, which is why I did this section or demo first, and we'll take a look at that in a second.
Yeah. And if you notice here, so like our original query, it looked like there were 3 predicates, but now when you look in the filters here, there are actually 4 because they changed the between to 2 different predicates.
Right. So the optimizer, very, very good. Yeah. So the optimizer basically changed around your my SQL statement, if you will, to make it more efficient so that it would work within the query framework that's available to it. So it can. So the optimizer is its ability to transform statements in essentially rewrite certain filter predicates to make it more efficient. And that's actually what it. Yeah, you're right. That's what it's done here. So rather than between
I think
2
it
and 3,
primarily just changed the between 2 and 3 to greater than or equal to 2 and less than or equal to 3.
Right. So yeah. So and then it uses that to push into the query. All right. So that's demo 1. And again, if you do have any questions, I'm looking. I don't see anything on the. Go ahead and post it in the Q&A. Be more than happy to answer those. I'm doing dual duty, so be patient. But we do want to get any of your questions, whether it's in regards to this or any other database and memory questions. All right. So what I wanted to do next was the kind of the function-based aggregation. So I have a little bit different query now with this. And what we're doing is I'm just selecting the minimum quantity and the maximum total order price from line orders. So I didn't put any filter predicates, no group by, so it's pretty much the simplest full table scan doing a couple of aggregations. And so these aggregations should be able to be performed during the scan of the line order table. And so our statistics again show us, again, we're looking at 111 IMCUs. Doesn't look like we pruned anything out because we don't have, although we might have actually, but we don't have a where clause predicate, so we can't use, we wouldn't prune anything out. So now we see that, and this makes a little bit more sense, that since we have 2 aggregations, so 2 times 111, 222 aggregations pushed down into the scan. And then notice again that we're only going to project back the results of each of the individual IMCUs, the 111. But we looked at all 60 million rows, and we're going to bring back, so we're aggregating on all 60 million rows. And what else of interest in there, Allison? Do you see anything else we should mention? Pretty simple example.
Yeah.
My point was just that not only can we push filter predicates, but we can also, I usually say function-based aggregations, because then when we talk about group by aggregations, that's really vector group by and in-memory aggregations, or even single table group by, which will be the next thing we'll look at, which is a different animal than these function-based aggregations where we can actually do, again, mins or maxes during the scan and total is up rather than having to wait for rows to be returned to the upper layer to try to do those aggregations. And again, another speed up that database and memory has. The only what I consider, although I guess I don't know actually the reason, maybe you do, Allison, but we don't show that information in the execution plan. So from that standpoint, from the execution standpoint, we have our query, whoops, which is somewhere in here. There we go. We have our query, and then we see that we did a table access in memory full, but we don't have any clue what work we might have done under the covers. So that's, again, one of the reasons session statistics are valuable, because then you can actually validate, did I take advantage of some other functionality within database and memory?
Yeah, it might also show up some in, like, if you have a SQL monitor report, I think you can see the number of rows. Oh, actually,
I don't think so.
I can't remember, because we still have to return to the upper layer how many rows we, like in the case where we aggregated, we still have to return this is how many rows that they aggregated, so that they can keep their statistics updated. But we still, just return one row.
There you go. And then let's see, I had one more demo. What I wanted to show, again, it's not as, well, it's a single table group by. So now we're a little more complex, but notice that it's, so I also have a blog post that describes the same basic query, but notice we're just accessing the line order table. So we're not doing any joins. So it's an optimization, like I said, we added in 12.2 to further speed up not only multi-table group bys, but even single table group bys. And so notice we have a where clause, but then we were grouping by ship mode. We wind up getting two different shipping modes, shipping by ship or truck, shipping by ship, and then the total values, in this case profit, that we're taking revenue minus supply cost. And then if we look at the statistics, kind of the same kind of thing. We haven't changed any of that. We have 111 still. We have our P code aggregation push down now only says 111, and
because there's only one.
We only have one filter predicate, and we really don't see from the statistics any other than the fact that we're able to aggregate that number. So that's how many rows get aggregated, and that happens. Actually, I think I added it. I did. So what I did is I kind of was thinking about this and said, well, how do I show folks that, we actually did the work? And so what I did is I just did literally a count for the where clause predicate. And so the total rows that pass that where clause predicate are the same value as 100. I didn't count them up, 1.7 million, 17 million. And so we see that the aggregation occurred on just the rows that passed the filter predicate. And so we were able to do that aggregation actually during the scan. So even though we didn't invoke vector group by, we were still able to optimize that to make it a little bit faster. Anything else you want to add? I don't want to do all the talking, but I also don't want to put you on the spot because there isn't really any other way. We don't call it out as we did a IM scan single table group by or anything like that. So
yeah. So then I guess the other thing to note is in this case, the IM scan rows projected is 222, and that's because for each IMCU there are two groups.
Oh, very good. Yeah, you're right. Yep, because we have two groups here. Good point. Excellent. So that can help, but again, you have to some of this you have to infer a little bit, and it could because unfortunately, and actually that would actually be kind of nice to have, is in the execution plan. We other than seeing the filter predicate being pushed down, we don't actually have any other information that tells us we took advantage of. And part of the problem with looking at an execution plan is that's what the optimizer thinks is going to happen. But then under the covers, once execution takes place, things go on at the scan level. This P code or this underlying code that actually works as part of database and memory to actually do the work. And so there's no easy way to report that back up to the execution layer, if you will. There's the same problem we have with join groups, which we've talked about, and the ability there's some fields that you can display in SQL Monitor active reports to determine whether join groups were used, but we are not able to necessarily have a two-way or pass back of information about all of the things that occurred during the scan. The closest we get is the session level statistics. So there's no direct way here in the execution plan to tell that we did leverage single table group by with database and memory, other than knowing that we actually did an in-memory access of the line order table. So, and with that, I think that's all I had for the demos and what occurred. I don't see any questions. So if any of you folks have questions, be more than happy to answer them. I do want to reiterate that we do have most of this information available in these 3 blog posts, and then again the information. Whoops, where did I go? I've lost right there. Oh, still missed it. Single table group by. Where did my? Okay, now we're just going to go through until I find. There you go. And then also the description of how the statistics work. So you can actually either with the base level feature on your database systems, or downloading the developer days, a VirtualBox, or our live labs. We now have a live labs hands-on lab available that we did another AskTOM session on, that you could actually just in the cloud go set up a live labs demo and run queries like this yourself. So we have multiple ways of allowing you guys to experiment with this and see kind of the benefit you can get with, the row store. Remember, we have you can always use the no in memory hint, even with indexing or without. So you can do all of the features of Oracle database in addition to database and memory. I will point out that our resources page, I think I have it up here as well. I have our blog. Yeah. So our resources page, which is blogs.oracle.com, actually, that URL right there. And on there we have all of our white papers and technical information and the videos. We also have our AskTOM Office Hours. So if you lose the link, you can get it there. Plus we have shorter videos that describe most of our database and memory technology on our YouTube channel. And then I do have the Live Labs link. So if you want to click on that and you want to set up a Live Labs, that's probably the easiest thing because you don't have to load up your laptop or try to get permission from one of your developer the DBAs to do your development database and enable database and memory, although you can do that with the base level. And then we have our other hands-on labs scripts so that you could actually run, and the Live Labs version actually has essentially the same hands-on lab that we've done at OOW, and I do it by example. So it's actually very easy to experiment with this yourself. So I would highly recommend that. Other than that, and then of course, just our normal database and memory blog posts. Here's our single table group by processing that we wrote. I wrote a blog post for, so you can go back and take a look at that. What did he mention? If you don't want to look at the video, if you want to be able to see, I talk about some of the statistics there. So a lot of information available. Other than that, I don't have anything. Does anything else you wanted to talk about, Allison?
I think you did a pretty good job doing a general overview. So, we definitely, we're continuing to do more improvements for P-code. It's still an active area of investigation and development. And so every release,
yeah, that's actually,
I know you keep mentioning 12.2. I am terrible about remembering features that we've added to each, but we have a team who just kind of like their job is to just make predicate evaluation faster and aggregate evaluation faster and be able to handle more. And
yeah, and actually in the since we had it in the 20C pre-release, the 20.3 pre-release, and the 20C documentation, although 20C is kind of not going anywhere at this point, we've really actually moved into a whole vectorization framework that's based, I believe, on this. And so what we're not I believe it is based on the P-code and how all of the pushdowns work. So we're actively planning on to a much larger extent extending the ability to do a lot of the work that formerly you had to do in the upper layers of the execution plan in the row environment, doing it in the columnar environment in the column store. So this, while this may seem simplistic, this is the basis of a lot of performance work we're working on doing in the future for database and memory. So you can take that as another thing of how valuable this work is to speeding up queries. Now that we're accessing this data, just the columns we need in CPU and memory, it makes it to get that extra oomph takes a lot of work, basically. So
yeah, and it's kind of funny because all of this work was originally done because we wanted to be able to push ORs down. So before in-memory came out, we were limited to pushing down into the data layer. It was like an AND backbone up to 4 predicates. So we could do like A less than 10 and B greater than 12 and C like whatever and D greater than 10. And that, like, anything more complicated than that, we couldn't push down. Like, again, we had to return. And so then we were like, oh, it'd be good if we could even just handle ORs. And then it's like, well, if we can handle ORs, why shouldn't we be able to handle ORs and ANDs? And oh, if we're doing this, then we might as well, push min and max. And so
yeah, so that's how a lot of those kind of things occur. Is you kind of say, oh, well, now that we can do this, can we do more than that?
Yeah.
Great. This hopefully, so we did, actually, I forgot to mention that. So we did population. I did population as almost a year ago with Mike Gleason, who's another one of our developers. And now we've talked a little bit about pushdowns. So my intent is to try to get a little bit more exploration of some of the deeper topics of database and memory, and pulling in some of our developers, because again, Allison, you've been able to give some insights that I can't, having not written the code, that I don't know about. So it's kind of fun to be able to hear from database development. And so if you, hopefully you enjoyed that, and we'll continue to connect. Since we don't have any questions, and I think we're kind of done, we will go
Dan
ahead.
has a question.
Do you see a question?
Or he says quick question, but hasn't entered it.
Oh, so I think your question is, so you said that the documentation does list some of the things that database and memory speeds up, things like queries, joins, group by aggregations. You didn't list that, but that is one of the other big areas that database and memory will speed up. And then you have on here a question: can DBIM be used only to make my joins faster? So can it? So you could take that. I would take that question 2 different ways. One, that's not the only thing it does. Could you make it so that is the only thing it does? So the bottom line is that it will make joins faster. One of the main ways it turns a hash join into a scan and filter operation, and it bypasses having to probe the hash table in the PGA, which we've talked about. And then you said, for example, if the query does not have analytics in it, would the join be discounted? Well, actually, since the decision to access the data in memory is a cost decision, if the optimizer decides that even though you don't have any other, quote, analytics, if you have enough filter predicates and maybe some aggregation, maybe not, if the cost of accessing the multiple tables, 2 or more tables that you're going to join together, is less by accessing it with database and memory and joining it in memory, then it'll choose that either way. So the optimizer itself doesn't really look for analytics per se. What it's looking at is the cost to run the query in the row store versus in the column store. And so, and actually it can be a mix. It could be that some of the tables it'll just access from the row store, maybe through an index, and some of the tables it may access in the column store. Typically, we only join 2 tables at a time. We can actually do more than that with a little bit of change in the way that tables are evaluated in Bloom filters. But the bottom line is it's a cost decision. So the answer to your question is yes. It would entirely be possible for hash joins to drive the cost down enough to access that data in the column store as opposed to doing those joins in the row store. Even if there aren't technically, quote, analytic, it's not an analytic query per se. And Dan thanks us, and yeah, thanks for joining and asking those questions. I don't see any other questions, and so I think we'll go ahead and close out this session. Thank you very much for attending. We won't have a November session because it kind of collides with Thanksgiving, but what we'll do is my plan is to have another session at the beginning of December, probably the first or second week of December. I will schedule that and put it out there. This session was a little rushed because of some other things going on, but I wanted to try to make sure that we were speaking with you guys on a regular basis. So hopefully you found this interesting, and look for our next session towards the beginning of December. And other than that, thank you, Allison, very much for joining us. I thought that was really nice to be able to hear some of the from a developer's perspective, some of the more internal aspects of database and memory. And we'll close it up.
Okay, I just thanked you and thanked everyone for joining.
Great. All right. See you next time, guys.